theoretical of casting here. In Java, we have a casting concept. So casting mostly used for this when you assign a value from one primitive data type to another primitive data type. So in Java, we have eight primitives data type. One is byte, other is short, other is char, int, long, float, and double. So these all are the primitive data type. Once you assign from one primitive data type to another primitive data type, or once you transfer or change from one primitive data type to another primitive data type, in that time we will go for the casting. So casting will have a two type. One is widening casting, and other is narrowing casting. So widening casting will happen automatically. Compiler will provide automatically. How? Because if you will go from this lower to higher, so these things already converting automatically. So see, cause converting a smaller type to the larger type size is called widening casting, and compiler will do automatically. If you want to provide, you can provide, not an issue. There is no issue or no error or no any compilations error will happen. If you are not providing, means compiler will provide automatically. But narrowing casting means manually we have to provide. When it will happen? If you want to convert from this larger type to a smaller types. So the priority is byte is lower. After that, short is compared to byte is higher, and then char is compared to byte short is higher, then int is compared to byte short char is higher, long is higher from this 4, byte short char int, and float is higher from this 5, and double is higher from this 6. So like that, if double is higher from all the primitive data type. So if you are converting from large data type to a smaller data type, means double to float, double to long, double to int, double to char, double to short, double to byte, in that case you have to provide manually, means narrowing casting will happen, which will be convert one data type, large data type, to the smaller data type. So we will see in examples how it is happening, widening and narrowing. So see here, this is the main class. Inside that we have a main method. Inside we have my int, integer type. My int is 9 is there. So this is integer, int, byte short int, third number of int. And again we have a double. So this is int, and this is double, my double. So my double is converting from this int, means integer data is converting to the byte double. So this is integer is lower than double, means lower to higher we are going, means integer data we are adding, integer primitive data we are passing in this double. Whatever the value of integer, my int is 9 here, so this 9 value also will be in this double. So automatic casting will happen, because int to double automatically cast will happen, because int is lower than double. So this is widening casting, so there is no issue. And if you will print SOP of my int, so 9 will be there. And if you will print SOP of my double, so my double 9 you have here, but this is double type, means double data type will call, so 9.0 will for this double data type. And if you will go for narrowing, so narrowing casting means manually you have to provide. So how you will provide? In this example, this is a main method. In class main method is there. Inside that we have a double. So double declaration, some point will be there, 9.78d is there. So this is double type, and one is my integer type. So we need to assign this double value to the integer value. So my int is there, inside that we have to assign my double value, means double value. So double is higher, then what we are doing, we are assigning from higher to lower, means downcasting we can say. Narrowing is downcasting, and this is widening is upcasting. So this downcasting is happening from larger to lower. So in that cases, how you will define? this double you need to provide in this integer type. So you have to mention list this thing int. Before this my double you have to provide this manually int. If you will not provide, compiler will go for this error. So manual casting double to int, you have to declare here integer type we are defining from double to int. Then if you will print my double, then double will have a 9.7 output and my int will have a converted 9.7d to integer type, means 9 will be printed. Another decimal to other point will be removed from this. So this is casting. We'll go for this examples why we are using and how in real examples. So this is byte, short, int, long, float and double. So we will check here in this section 7 casting 1. So this class A is there, class A having casting 1 package, and this class A have main method. Inside this main method same I declare integer I equal to 10. Now what we are doing, we are assigning I value to double value. So double J assigning some I value. So if you are doing from lower to higher, compiler automatically will provide, and that is called this one. That is called wide casting. Wide casting we can say upcasting from lower to higher. So upcasting is happening. Either if you can do this, else compiler internally, if you are doing, if you are not providing, compiler automatically provide. If you want, you can make it like that also. Double J, and then here you have before I we have mentioned double, like whatever we are doing from this downcasting, the same way declare here. So that is also not an issue. This is also don't have any issues, like directly you can provide either this way also and this way also, because compiler will understand, because from lower to higher we are going. So either we can declare this way, line number 8 or line number 9, this way, both is fine, no issues. But for this higher to lower, we have to declare this 9 way, line number 9 way, this way we have to declare. We have to mention this which type we need to convert. So if you run this program, these all concept we are using in real time. So thus done is the output will happen, because both are valid statement. Coming for this class B. So this class B have package. This package is section 7 casting 1. And then class B main method is there. Main method have byte. So series is always byte, short, int, long, float, double. Byte is lower, double is higher. So here what we are doing, byte is 20 and int we are converting from lower to higher. Byte is lower to higher we are converting, means byte to int, no issues. Directly we can provide int I equal to b, means whatever byte value will be there, that will be converted to the int value here. Int I equal to b means byte value, or else you can also provide int I equal to int byte b. So this also we can do, not an issue for that. So this will show hello world will be the output for this. Here we have a class C main method. This is sort. So sort is also lower, byte sort, the second one sort is this. So sort is also lower, so sort to double we are going, fine, no issues. So directly we can go for this sort value assigned to the double value, means I value, sort I value is assigning to the double value, is fine, no issues. So output will done. Class D, class D have int value. Int to float is fine, because integer is this one, line white short int, and float is line priority of second highest. So it's fine. Int to double float is fine, means upcasting is happening. Upcasting is happening means no issues, compiler will provide or understand this way. So I value will be printed as a 20 here if you are printing SOP, and F value means this float value will be printed because we are assigning this I value of 20 to the float. So the float value will be taken, not I value. So if you run this program here, so 8 is a I value and 9 is a float value. Float value will be 20.0 something will be there, and done. Then this is the next program here. This program have in this class E have a static test method. So this test method have parameter, double type of parameters is there. So casting will happen either variables, either in method parameters or constructors. Everywhere it will be applicable. So this is a method, a static method, and void type means no return type, and this is name of test method, and parameter is double I means double value, double type of will take, reference is I, SOP is there. Compiler will go for the main method. So main method what we are doing, integer I. So what we are putting integer I value assigning to this test I. Test I means this is integer I. So this test method we are providing integer type of value, integer I, and then this test method compiler will call because test method is available inside this class E. But we are providing here line number 11 as a integer, and but in line number 4 is a double type, means that will be applicable. Why? Because of offcasting is happening from this method level, from integer to double is happening. So that is fine. This priority integer to double means integer is lower, double is higher. So this will be applicable. Now if you will print SOP, then this method will call from test double. This test double will call and then done. So if you run this program here, test double and done. And suppose if you have some return type will be there, then if you return, then double value will be returned. But here void, so no return type. So casting will applicable for the constructor, method, variables and all. Only we can concentrate about this one. This primitive data type, byte, short, int, long, float, double. So this is the sequence. Byte is lower, double is higher in that. So class F still again have a static method, double test. So double, this is a double type. A static method double type means will have a return type something, and then test method, this is no parameters. Now compiler will go for the main method first. So main method we have a SOP, inside that we are calling test method. So test method is no parameters means this test method will call, and in this test method we have integer I is there. Now what we are doing, return I we are doing. So return I means this is integer type, and the parameters which we have declared a static double type here. So we are declaring here I, and this is double type. So that is fine because return I will be assigned to the double internally. Why? Because from lower to higher. So no issues for that. If you run this program, what will happen? SOP will print this I value as a 10. But what we are doing, return type is double type here. So return I will be converted from the double. So double is 10.0 will be printed here. 10.0 is the output for this casting. Understand?
Yes.
So the next is class G. So this class G having a package, then we have a class G. This also have a static method, integer type means he wants some integer type, some return, integer type of return statement. And this is a test method, and here what we have, byte parameters. So this is a parameters byte. Now compiler will go for the main method. Main method have a byte b equal to 10. So this will be executed byte b equal to 10. Now SOP test b. B means this current number, line number 10. Test B means test byte 10. So test 10. Compiler will check any parameterized test method is available inside this class G. Yes. So this test method is there. So this is parameterized byte to byte because we are passing byte B, and here also required byte B. So no issues. Compiler does not have issues because byte is fine. Either byte or higher, any higher value. If lower, then manually we need to provide. We will see later. So here byte type we are providing as a 10 here in this line number 11, and the compiler will call this test method, and this 10 value will assign here byte B. This B reference will assign 10, and return also we are doing B. So B have 10. So the output is 10, but this is byte. So this return is byte here. This line number 6 byte value is 10 here, but this will be assigned to this integer because we need integer type. A static int test is there, so we need integer type. So that is fine because we are converting from byte to int. So output will be 10 only. 10 is there. All our upcasting concept which we cover right now, all our upcasting is there. So this is section, the class H have also method, test method. Test method is sort type here, and compiler will go for main first. So main method is static. Here we have a byte type, 10 is there. Now what we are doing, double type, here we are assigning byte. Test byte means this byte value is 10 will be assigned here in this test method. So this test B. So test B, first we will call, the compiler will call this part test B here. So test B, whatever the return statement will come, that will be assigned to the double. First byte B equal to 10 has assigned here, B equal to 10 means test 10 is there. So compiler will execute this line first. Test 10, either test 10 available inside this class class H, yes. So this test have some parameters, 10 we are passing, means some parameters already test have sort parameters is there. So compiler will call this test sort S, means here we have a byte to sort is fine. So here we have a byte, we are assigning byte value to the sort value here. So that is also fine, no issues. Now whatever the sort value has assigned here 10, this value we are returning here because we have a static int type test. A static int type test we have. So some return statement should be integer type, but here what we are providing, sort type, because byte has converted to the sort here, and sort we have return statement. So this return statement will be converted to the integer because this is upcasting is happening. So by default return will consider as an integer here. So this integer, so right now this this test method value is 10 here, right? Test method value is 10 here because we are passing a static int test. So this method is executed, and this byte value has assigned to the sort value, and sort return type has assigned to the integer value. So integer 10 will come from here, and this will be assigned here, this test B. Now what we have, this is integer type, whatever the data is coming, value 10, 10 is an integer type here, not byte type, because byte has already executed. Now this value is 10, integer type. So this integer we are assigning to the double. So this is from lower to higher upcasting. So no issue. So once you execute this program, means double will 10.0 will be the output for this D. Right? Understand? Okay. So like that upcasting will happen. We will see the downcasting. What is the difference of upcasting? and downcasting why we are using and when to use in our project. Mostly while we writing the service logic, business logic, in that cases some of the primitives data type we need to downcast or upcast. That cases we are using this concept in real time. So this is right now see, this is a static method, one static method, and this is second static method. We will see later. First compiler will go for the main method. Main method have byte b equal to 10. So this 10 is there. Now this 10 value has assigned here test1 10. So right now this 10 test1 10, compiler will check if any parameters is there. Test1 method is available with single parameters. Yes, compiler will able to find, yes, line number 4 test1 is there with single parameters, but here integer I is there, but here we pass byte as a 10. So this will assign as a 10 value to the integer, because from lower to higher is going, that is fine, upcasting is happening. So right now integer 10 is there, and this method is a static float, means float type he want, so return should be float. But here what we have, test2 is there, test2 dot I. So I value is 10 here, this value is 10 because byte converted to the integer, fine. So right now I value 10 here, so this 10 has came here. Now the first we have to execute this one, either test2 have 10 means test2 method is there which have single parameter integer type. Yeah, test2 method is there with single parameter integer type is there, same because here also we are passing 10. So this will be assigned to this and I as a 10 here. Now return should be long. Why? Because the static long test2 method is there, so return compiler expect long value, but here I we are returning, so I is integer type. So integer to long automatically will assign, automatically will transfer, compiler will do integer to I. So right now I value as a long here, so this will go from here. So this is long, return type right now here as a long I as a 10. So long 10 value is there. Now he want a float. So this is a long value, okay, and he want float. This is static method, fine, this is static method integer. So this test2 have a long, just a minute. So compiler will go from this, so b if d, so d is this one, so this test1 has called this test1, this test1, test2 has called this one. If you run this program, 0. Yeah, so see here this one, first main method call. So main method have byte b equal to 10, so this 10 has assigned here as a test1. So test1 have a b as a 10 byte type. So compiler will check test1 is there or not, test1 is there, this is integer type, so this is fine, assigning from lower to higher. Then integer type of I has passed here, so this return type has integer type, but this required as a float type. So first this will be executed. So here test2 int I is there, I is 10 type, but 10 this is float type. So first here what will happen, integer to float is fine because this is fine, upcasting is happening here. So return is float means this test2 having some 10 value. So now 10 value means integer type, so this integer type is there. So int 10 is a integer type. Now what we are doing, integer to long. So this is integer type, now we are providing as a long here because static long is there, so return is integer, that will be converted automatically to long. So right now the whatever the 10 value is there, long type. So this came here. This right now is a long type. 10 is as a long type. Now we are converting long data to the double. So this long data is fine. Long is here. So long to double is fine. Upcasting is happening. Then if you will print this SOP, 10.0 will be there and done will be there. So how this concept is happening? Because of this topic only. So this is one small topic is there, Java typecasting. So Java typecasting is nothing but when you assign a value from one primitive data type to another primitive data type. We will do by using two way. One is upcasting. Upcasting we can say automatically will happen by the compiler, or we can say widening casting. So from lower to higher, if you are converting the data type, then easily we will do this. If you want to convert from large to smaller data type, means then like double to float, double to long, double to int, then we will go for the narrowing data casting. So this is the examples which we seen, like how upcasting is happening and how downcasting is happening. So downcasting we have to provide internally, like manually we have to provide either which type of data type we need to cast. So manually we have to provide while we converting before that. But in upcasting, if you are providing is fine, if you are not providing that also is fine, because compiler automatically will be taken care. Automatic will happen from int to double, because lower to higher, this is happening from higher to lower. So based on the data type, whatever the casting will happen, based on the data type output will show. So the same way we are checking here how this all will work. So right now whatever the example till now we seen, all are upcasting related. We will see downcasting also after some examples. So again we have this is test1 method, test2 method, main method is there in this class J. So compiler will execute this main method. So main method have byte b equal to 10. So this byte type. Here what we are doing, in this variables double d, we are calling test2 b, means byte type we are calling in this test2. So compiler will check test2 method is there which have single parameters byte type. Yes, inside this J class, yeah, inside this J class test2 method is there which have byte parameters, same, yeah, fine. So here byte b was a 10, so this value will assign here as a b as a 10. Now we have a return statement direct. So return statement have test1. So in this test1 we have to call as a byte. So byte is 10 value here. So test1 as a 10, but this will be written as a float. Why? Because of we have a static float type, we need a static float type. So compiler will assign as a return to byte to float here. So right now test1 have any float data type. So compiler will check any test1 method is available which have single parameters and float type. This is a static float type. This is byte test2 will call here, test2 have a byte type, so byte will be assigned here test b, and then b have test b. This test b has a byte type, right? Byte type, then byte has a float, and this test1 float to byte to short. If we run this program here, 10.0 done this, because double is there, yeah, that's fine. In this I we have a float and long, in this J we have a float and short. So byte to short is fine. Yeah, so in this case what will happen, Line number 8, right now we have a byte type because byte 10 has been assigned here in this test2. So this is a 10 here. So byte 10 as this. Now compiler want this method as a float type, but return have a test1b. So test1b means this byte type will assign here, and this is a float type. So this method will behave like return test1 as a float. So b is 10, so that will be assigned as a float 10. So no issues, test1 will be, compiler will check either test1 method is available with single parameters. Yes, so test1 method available with single parameters. So here some float value is there, so that will be assigned here test1 dot byte k. So this is byte k, and while we return this k value, here 10 will be there only. So 10 will be coming because single parameters which is available here as a float type, which assign here, and this k value has a return type as a byte. So this float has converted to the k here, and k is a return type as a byte, and this byte will be internally convert to the sort because he want a static sort test method is there. So sort will be assigned to this return type. So right now byte will be converted to the sort here, and then this test2 method will have a sort method. So sort method of 10, and if you want to convert sort to, because conversion will happen here, so if you want to convert sort to double, because here we are converting sort to double, so double from lower to higher means upcasting. So output will be 10.0 and done. We'll see this next one. So next one is a downcasting. No, this is also upcasting. Here main method is there, compiler will go for this main method. So this is integer type. So what we are doing, integer to double we are converting. So if you are providing this also not an issue, because this integer value, before that we provided like what type of value I want to convert. So either this int I value we are converting to the double. So before that if you have defined, that is fine. So compiler know, oh, you want to integer to be converted as a double, and you are assigning to the double j value. So that is fine. And if you are not providing this, compiler also does not have any issues because we are providing from lower to higher. So upcasting will happen. Upcasting means this one will happen. This concept will happen, widening casting. So this is converting from a smaller type to the larger type. This concept. So in that cases automatically will provide. If you want, you can provide manually also, no issues. So the output of I will be 10, but output of j will be double type because this is double type. So double type default value is 10.0, and integer type is default value is 10. So here what we are doing, we are printing j value. So j is double type means 10.0 done. Now this is a m. So main method byte is there, int is there. Now what we are doing here, int j we are converting byte value. Now suppose byte is 10 is there, so this 10 value we are converting to the int, that is fine, correct. Upcasting is happening. Again right now b value, this is byte type, so we are converting to this integer type. This also is fine. Byte type we are converting to integer type means lower to higher is fine. If you providing this int, whatever the type we are converting, before that is also fine. If you are not providing, that also fine. We can say explicit typecasting also. And this is double. So double we are converting from integer because I is a integer type. So this I value as a integer, and integer to double we are converting is fine. Again we have d I value, so this is integer type, again we are converting to the double, but we mention here the conversion, double conversion. So this is also fine. If you are providing, is fine. If you are not providing, that also fine. for this upcasting. So if you run this program, so this j value double, sorry, j value is an integer type, right? So this j is an integer type, so this 10 will be printed, and d2 value is a double type, means 10.0 will be printed, and done. Now here in this n class n method we have a static method, class n having a static method, and then this is a main method. So compiler will run this main first. So in this main method we have an integer I equal to 10. Now we have a test method. So test method, they are passing I, means integer value they are passing here. So compiler will check either test method is available which have single parameter integer type. Yes, test method is available which is double parameters, means I to j, means integer to double is fine. So this I value 10 has assigned here, so which will be assigned to the double j. So double d has 10. Now this is void type, return type is void, so there is no return type here. So this conversion has automatically happened, no issues. And then this SOP will be printed because we don't have any return type. So integer to double has converted automatically. Now this SOP will print it, and then again we have a test one which have double I, means I we are assigning to this test. But before that we mention as a double, no issues, because either if you are providing as a double here is also fine, if you are not providing is also fine, test I. Why? Because of integer to double you are converting, means lower to higher. I is a integer and d is a double, so that is fine. So if you again, this test method will be called. Why? Because of integer you are converting to the double, so that is fine, lower to higher. Again this is no return type, void is there, so SOP will be printed, and then this SOP will print, and then hello world. So if you run this program here, see form test double, then dash dash dash, then form test double, hello world. Now we have a class O, we have a static test1 method, integer type, so should have a return type. This is also a static in test2 method, have return type integer, so should have some return type. Main method is there, compiler will go for the main method, so we have a double d, this test1. So test1 have no parameters here, so either compiler will check test1 method have a no parameters, yes, inside O class, yes, O class test1 method is there with have no parameters, fine. Now we have a byte b equal to 10 here, so we are assigning return as a byte value here, but compiler want a static int type because integer type of test1 is there, so return statement should be integer type. So byte should be assigned internally as a int type because casting is happening from this byte to int as a upcasting. Then compiler come to this line number 17, d2 equal to test2. So test2, they are, the compiler will check either test2 is there, test2 is available with no parameters method, yes, there. So this test2 having byte b equal to 10. So here what they are doing, they are returning byte b value to the integer because they mention here int, if integer type. So byte b have integer, if you are providing this also is fine as a int, if you are not providing this also is fine because lower to higher you are going, so no issues. In this method also not an issue if you are doing because of double, because you are going from this integer to double. So whatever the integer return will come from this test2 method, what we are doing here, we are assigning to this double. So manually we provided as a double here, but compiler automatically will provide, no issues. So the output for this d d2 as a double value will be printed, and d1 also double. So if you run this program, double double, and then done. So this is class P. Class P have main method. Main method is double D equal to 10.0, because default always all have default value. So double should have 10 point something will be there. Float should have 0.0 or some value dot f will be there. Integer should have some numeric value and all. So you can check all the default value, all the data type, primitive data type default value. Suppose if you are not providing, so byte will have a default value 0, and range will be from this to this, and sort will have a default value 0, range will have a this to this, and integer will have a default value 0, long will have a default value 0. But these all are the default value. So characters have default value this one, boolean have default value this false, byte, short, long, int, long have L, float have 0.0 f, double should have 0.0 d, like this. So these all are the default value. If you are not providing, compiler will automatically provide this default value. And this is the size, 1 bit, 2 byte, 1 byte, like this. So these all are the size of all database. So here this is double D is 10.0 we've already provided. So this is double type. Now what we are converting double to int. So see here what is happening. From higher to lower we are converting. This is higher, so double to int we are converting. So D1 has double type. So here we are converting double type D1 to the integer type of I. So this won't be happen. Compiler will show error. This is downcasting. So type mismatch cannot be converted from double to int. This is downcasting. So upcasting and downcasting. So downcasting, manually we have to mention this here int I, like what type of conversion you want if you are going from this lower. So manually you have to provide here. Compiler won't be providing. So if you will provide, then fine. This will be double to int will be converted. But if you are not providing, so it won't be converted from higher to lower. So this will have a error, type mismatch error. So always in real time project, some of the time you will see like type mismatch error is coming, won't convert this data type and all. So these things will happen from this casting concept only. So this is a casting of queue. So queue have main method. Main method has double type. So this is double type 12.9 D1. Now again we are converting D1 to integer type. So here we have manually provided. What we provided means D1 we are converting as an integer. This means we already provided compiler, inform compiler like D1 is a double type which I have to provide to the integer. So we mention here as an integer. Now this D1 data will be provided to the integer I. So what will be the output of D1 and I? So D1 output will have a double type means 12.9, and I1 output will have a 12, because this assign D1 has assigned to the integer type. So integer type point will be removed. So only 12 will be the output, because default value of integer is 0 and default value of boolean is 0.0 d. So that's why point will be taken here in this double. Coming for this R have method, a static method. Now we are considering all are the downcasting concept here. So we have main method. Compiler will go for the main first. So we have a static, sorry, byte b10. So byte b10 we are converting. Yeah, byte b10 is there and double d 10.0 is there. Is fine. We declare two variables here as a byte and double. Now we are calling test1. So test1 as a b type means b is a byte. B is a byte type. So compiler will check either test1 method is there which have single parameters. Yes, test1 method is there which have single parameters, but they need integer I. We have a byte, means byte to int is fine. This will be came here. So whatever the data of byte b 10 which will be assigned to this int I, this value. Now this is a void type, means no return type, means this I value will be printed. I value is 10, so SOP of test 10 will be printed. Now again compiler will come for this line number 13. Again we have test1 method. Inside that we have d1. D1 is a double type. So double, compiler will check either test1 method is available which have single parameters. Yes, but they need integer type. But here we have a double type. So double type is there. So double to int, manually we are providing this, we are converting double type higher to lower, then it will be applicable here, and then output will be test I value. So if you run this program, so upcasting and downcasting will be applicable for method level, variables and all. So this casting is happening from the method level here to this method. So double d1 we are converting to the integer. So manually we provided here integer. If you won't provide here as an integer, then see here we have a compilation error. The method t1 int is type of r is not applicable for this argument of double. T1 have integer type of I which is not applicable for the double. Either we have to mention manually. So this is a class S. We have a static test method and main method. So compiler will go for this main, and main will have a long. So this is long, but inside that test1 single parameters we are calling as a 10.0. So compiler will check test1 as a 10.0. So compiler will go for this single parameters method is available as a test1. Yes. So this is double type, means this 10.0 assigned to this d1 value as a 10.0. Now this have a double type. So what we are doing, from double to integer we are converting. So manually we provided, because compiler want this method return type should be integer. So in return statement what we are doing, this is double type of d1. So manually we provided int here. So this will be converted as integer. So if you remove here, so you will get a compile time error. Mismatch cannot be convert double to int because this d1 is there and compiler want an integer type of return. So either you have to manually provide here. So this is narrowing casting, we can say. Narrowing casting will have a explicitly casting or down casting. Widening will have a type upcasting or implicit casting. This is class T. Class T have main method. So this is double have a float, and inside this float, see double d1 we are converting to the float. So double is higher, float is lower. So manually we need to provide the conversion. We need to convert as a float. So compiler will understand that. So d1 has converted to the f1. float. Now what we are doing, we are converting from f1 to integer type. So f1 data will be converted to integer, but manually we have to provide. Now integer data we are converting to this byte type. So this is also lower. So we need to provide here byte. So if you'll see this output here from D1, F1, I and B, so all this value will come like what is the default value from I, byte, float, doubles. Based on that, this will be printed. See, double value is 10 point something, like 0.0 D is there. So like that, double value is 10.0. Float value is also some point will be there, so 10.9. Then integer should have 0 value default, so point won't take, so this default as the output will have a 10. 0.9 will be removed from there, and byte also have a 0 default, means point is not there in the default value. Like that, 10.9 means 10 will be printed here as a byte. So these all will be applicable based on the default value. What are the ways we are writing as a default? That way we will consider either point or without point. So this also we have to define like what type of data type we need to define. Suppose if have employee have a password. So employee have a password that as a defined as a variable. So this password will have a some 8 characters length, 10 characters length and all. So based on the size we are defining data type, either integer type, short type, float type, double type, characters type and all. So this is class U, we have main method. This is integer type of I is 10 value. Now what we are providing, integer value we are providing to this short value, but integer to short. See here. So this is the, these things you have to remember, or data type. So here what we are having, integer to short we need to convert here, integer to short. But before that we have not mentioned the short, we mentioned byte here. Why? Because of byte is a smaller one. So a smaller to higher is going now. So first what we mentioned here, integer, we converted manually, compiler knows like this is byte type, because manually we mention here as a byte. So integer data has converted as a byte. Now what we are doing right now, this is a byte data. So byte data we are converting to the short here. So compiler have no issues, because compiler understand byte data they are converting means lower to higher. So internally it will work. So no issue in that cases. This way also you can declare. The output will be done. So always you have to remember byte, short, int, long, float. Byte will be the lower. After that higher is short, then higher is int, then higher is long, then higher is float, then higher is double, like this. So this is the package which I have casting section 7 casting 1. Now we'll go for this next class, class V. So we declare package, then we have a class B, then main method. This main method have double. Now what we are doing, double to int we converted here, because manually we provided from lower higher to lower, double to int here. So compiler know this is integer type. The data here is integer type. Now for this integer type we are converting to the double long type. So now this is happening from lower to higher. This happened from double to int as a lower, means manually we provided. Now this is integer type. Now we are converting this integer type to the long type, means lower to higher. This automatically will provide castings and so suppose if you will provide like that also no issues, because what happened, double d1 double d1 we converted as a integer first. Directly we are not converting as a long here. So what we have converted, double d1 to lower, higher to lower we converted. Now lower to higher we are converting, integer to long. So either you have to mention directly, or if you are putting this long also, no issues, compiler will take. If you are not taking, if you are not putting this also, no issues. So automatically compiler from lower to higher, no need to mention like this. Only we have a lower to higher, will no need to higher to lower we have to mention that. Means upcasting no issues, downcasting we need to mention. So this is class w main method have double type of variables. So this variables, what we are doing here, multiple casting we are doing inside this line number 7. What, first double to int means lower, downcasting is happening. So double to int if you want, so we have mentioned int d1 means this d1 as a double type we are converting to this integer. So this is right now integer. Now what we meant, mention this integer to sort means this is also downcasting. So this data is right now integer, so integer to sort is downcasting, so mention as a sort here. Now again integer to sort, so now this is the sort data, so sort to byte we are converting. So byte is also lower data, means manually we provided. So this all data as a byte here. Now what we are doing, byte to int we are converting, means lower data to higher data, means upcasting. So no need to have any issue, either if you are declaring this int or not, there is no issue, because right now this data will be converted from integer to integer here. If you are providing is fine, if you are not providing is also fine, because this data is right now as a byte form. Last one is a byte form, this is a byte form, whole data. Now this is converting to the integer, so it will print as an integer, so integer output will be there 10. This will be 10. Coming for this next, this is a main method. Class X have main method has double. See here inside this test method we are calling SOP having test1 method. So in this test1 method also we are doing multiple casting. So how, this d1 as double type, so first we are converting d1 to byte, means upcast downcasting, double to byte, so manually we provided. Now we are providing d1 to byte, means double to byte. For this byte now we are converting as a sort, so this is also downcasting. So right now the data is a sort type. So test1 have single parameter sort type right now, which have to check either class X having test1 method is there which have single parameters, yes, but this class test1 have, so sorry, test1 method have integer type, but this is sort type. So sort to int is lower to higher, means upcasting is happening, so no issues for that, directly we can assign here. But this I, we are printing return type, so return type as an integer here, but we need a double. So I integer to double is fine because upcasting is happening, so no need to do manually. assign here as a double. If you are assigning is fine, if you are not assigning also fine, like this. So this way we completed casting, upcasting and downcasting. So if you want, you can go for this reference here also, just 2 line of casting here. What is Java type casting? We have a 2 type of casting, automatically and manually. When to use automatically, when to use manually, we will see later once we will go for the real project. But this is the way which we use the casting. So most of the, if you will go for any project, yesterday also we seen like in Java T point also have some project, or if you will go for that project Spring Boot or full stack project, there also we have a many where we are using a concept which have a castings and all. So these all are the project, and if you will go for the full stack, so Java guide there, if you open any of the code, there you can see the casting we are using. We are using many where in the casting concept, mostly we'll have a Java service implementations, we are using casting concept. Java guide GitHub is there, so in that all the project is there. Any one of you can take, but here we have all the free resource of Java guide. So this is Java. So here we have a multiple project like is there, 247 projects are there, but we need to go for the full stack here based on the Java project. So if you search here Java projects, so this is suppose a Spring Boot REST project is there. So here we have SRC. In SRC all the Java code will be there. So in main method, this main method, we have a Disney project. So Disney Hotstar, I think. So this related project is there. We have a controller, model, repository, service, util. So these all are the package they created. Inside this, if you will open any service, so service should have a implementation. So these all are the Java, and this is impl file. So if you open any of the Java file, so see here, these all are the interface and abstraction is there. Interface and abstraction concept will be covered here. So these all are character service. This is interface. So this interface we have a multiple abstract method is there. See, these all are the abstract method is there. These all are abstract method. For that abstract method, implementation should be provided in this next class. So where they have provided inside this implementation dot package, implementation package. So if you'll go for the character service, so here we have a character service dot impl. Impl means implementation class. Here they extended character service. So character service was a interface. So here they implement, because this is class and this is interface. So class and interface they implemented. So whatever the functionality has written there in this character service interface, all the abstract method, we have provided the implementation here. So last time we discussed interface abstractions and all. So these things we are covering in all the project. We are writing this service logic. So all the service should have a abstraction and interface concept will be taken care. Can we continue on today or next? Tomorrow we'll show you where we are using the casting in this real-time project, or else you can go through this all the service file. In that service, somewhere we are using a casting. This is the service. Every project, if you open this service, so inside this service we have a implementation, or we have a some Java class, means some interface class is there. So in that interface, if you'll go for that, somewhere we are using casting also. In repository also we are using casting. So just open this file and then check either we are using casting or not.
Somewhere I saw that in casting they are using the angular bracket.
Yeah, Angular also will use casting because Angular also have similar topic in that.
Brackets.
Uh,
The
uh, uh,
angle brackets.
Show me like which is related for cast, like same data type casting or different casting.
It's a same casting.
Yeah, Angular also will have.
No, no, I said the bracket like angle brackets. So we can use the angle bracket also for casting.
No, no,
The
that is different. Here casting is different. That casting will have a different. Uh, I'm not able to see here. Open any other project. Inside that many projects are there. If you open or not here anywhere, if you'll go for that, you can find it some of where we are using casting. So you will easily find, or else tomorrow we'll show you like where we are using casting and all. And can we continue here for this second casting?
we will do tomorrow.
Okay. So this is casting as well as object creations also will be covered in this part. Section 7 casting 2. Here we will consider all the object creation, how we are doing object creation, how we are calling all the parameters of object and castings and all. So this will have a many program inside that. Also please try to check all the casting where we are using whatever the topic we cover. If you open any of the project, inside that if you'll watch properly the code and all, you will see this all the concept inside this main. You can go for this controller model repository service or util. Somewhere you will see all the topic, either import, either package, either variables, either access modifier, either constructor, either this, either super, either have a casting, either interface, either abstract class, and increment, decrements, and all will be there. So till now, whatever cover, everything we are using while we are writing the project. So this is Disney Hotstar project, I think. Someone has created this project based on this. So you can check here also.
Mhm.
Okay, then tomorrow we will continue this next.
Okay.
Thank you, everyone.
Thanks, everybody.
Yeah.
Thank you.